Okay, today we're going to do lesson 4, domain and range. And let's quickly fill out the review here. The x-intercept of a graph of a relation has the y-coordinate with a value of 0, so something like x comma 0. And the y-intercept of the graph of the relation has an x-coordinate with a value of 0, so it'll be 0 comma y. Okay. All right, let's look at what domain and range are. Let's read the official definition, and then I'm going to try and give you my interpretation of how I like to look at domain and range. Okay, so the domain of a relation is the set of all possible values which can be used for the input of the independent variable x. And the range of a relation is a set of all possible values of the output of the dependent variable y. So what I want you to start associating is that the domain has all to do with x, and the range has to do with y. And the way I like to think about it is for the domain, I like to think of it as in the horizontal direction, and for the range, I like to think of it as in the vertical direction. And you're going to see why that makes sense in a little bit. So again, the domain is all the possible values, all the possible x values, and the range is all the possible y values. Okay, let's go ahead and okay, let me come up with my own example here, and then before we jump into these ones down here. So let's say my graph, okay, let me just do my coordinates, or my draw my axes here. Okay, let's say my graph is goes from here to here, okay, and it stops there, and it stops there, okay. Well, the way you want to think about domain would be all the possible x values from there to there. So I'm going to color all the black here. That would be the domain. Whoa. Okay, and then the range would be in the vertical direction. So the range would be from all the way from here to here. So the range would be right about there. Okay, let me extend my graph a little bit here. Okay, so again, that's one way of looking at domain and range here, is what are all the possible y values? Well, all the possible y values start here and end over here. And again, that corresponds to, I'm not sure why that's happening, corresponds to really the top limit of your range, and this corresponds to the bottom limit of your range. Likewise, for the domain, this corresponds to the far left boundary, and this corresponds to the far right boundary of your domain. Okay, let's go ahead and do some of these examples. Now it says list the domain and range. So the domain, so I would say x, let me put it like this, x can be 1, comma 0, comma 3, comma 5, comma -3. Basically all the x values, okay? Then the range is going to be 2, comma 5, comma 8, comma 9, and comma 2. All right. Okay, example number 2, let's see if we can determine the domain and range from the actual graph. And this is most of the time you're going to be doing questions that require you to interpret a graph here. So let's look at all the x values for this one. First of all, let me just color these guys here. So these are all the points that we're looking at. And so what are all the possible x values? Well, we start here at about -4, -3, that's -4, -3, -2, -1, 0, 1, 2, 3, and 4. So the answer here would be for the domain, domain would equal -4, -3, -2, -1, and 0. But also 1, 2, 3, and 4. So I'll just make this plus or minus, plus or minus, plus or minus, plus or minus. Okay. Again, it's really important to notice here that if I had something like 3.5, that wouldn't be in the domain because 3.5 would be right about here. And as you can see, that entirely misses the dot. So that, your domain has to be an actual value on the graph, and 3.5 is not. Okay, let me do the range. The range starts, again, where do we start here? What's the lowest possible y value? Well, the lowest possible y value is 0, because the lowest point are these two red dots here, and they're both their y-coordinate is both 0. Okay, then the next one is 1. These are 1s. These guys are 2. These guys are 3. And finally, the highest range there is 4. Okay, now let's go ahead and look at the next one. The next one here is very similar, except now, let me do the domain. The domain now is going to be like this. We're going to write it like this because x is continuous. In other words, it can take on every value from -4 to 4. So how do we write that? We have to use an inequality. We have to say x is between -4 and +4. So what I just did here, if you remember your inequalities, I'm saying that x can be greater or equal to -4, but it has to be less than or equal to +4. Okay, so that's how we write that. Obviously, we couldn't write every single point because there's an infinite amount of numbers between those -4 and 4. Okay, the range is, it goes from, so again, the range is y, and it goes from 0 to 4. Okay, and again, I'm going to read this in a sentence. What this says is that y is greater or equal to 0, but less than or equal to 4. Okay, the last one is also very similar, but there's also a bit of a twist on it. The last one here, what it says, the only difference is these arrows, and that is a big deal because what the arrow does, it tells you that it's going on forever and ever and ever in this direction. So if that's true, then how we write it is x, and then we do a little funky e like this. That's the Greek e, and then the big R. What this says is that x belongs to all possible numbers. Remember, R stands for real numbers. Real numbers. And so what I'm saying, and this little e here stands for belongs to or in the set. Okay, so x belongs to all the real numbers, and that's true, right? If this keeps going forever on both this way and this way, okay, it'll keep going forever. Y, on the other hand, is here's how we're going to write y. Y is less than or equal to 4. So it's very similar to this one. It's actually just this portion of the other one, and here's why. Again, what is the ceiling? I like to call the ceiling here, what's the highest possible value of y, and that is 4. Okay, because if that's 5, that's 4. And then what is the lowest possible value? Where again, the lowest possible value is -infinity, because again, these arrows say that we keep going forever. So really, I can write it like this. I can write it as -infinity here, but we don't write that. We're just keep it simple and say y is less than -4. And what that says is that y can take on any value as long as it's not greater than 4. So it can be really negative, a million if you want. If you wanted it to be a negative million, that's totally fine, except it would be, a kilometer away or something. Okay. All right, let's keep going here. Let's do a few more visual examples. I'm going to go through these a little bit quicker now. Here's the domain. The domain here, x is all real numbers, because again, this keeps going forever this way. And the range, y is greater than, and 1, 2, 3, negative 3. Again, now we, as opposed to a ceiling, we have a bottom here that, anything over here is not a possible value of y. Anything above is okay. So anything above negative 3 works. So we say y can take on any value greater than 3. All right, let's look at this one. I'm going to do my domain. Let me just write D for domain. Keep it simple here. That's a terrible D. Let me fix it up a little bit. There we go. The domain would be, and let me do a couple dots here. Again, the domain would be all the way left here to all the way right. So what is the furthest left here? This boundary is negative 2, and this boundary here is 4. So x is greater or equal to negative 2, but less than or equal to positive 4. And the range is very similar. Okay, the range goes from here, that's the ceiling, that's the lowest point, and the ceiling is at 1. And the basement, or the bottom here, the ground level, is at negative 3. So y is going to be greater than negative 3, but less than or equal to positive 1. Okay. Again, don't worry so much about this one here. Let's go into D, a circle with the center. Well, I'm going to have to graph this circle here before I can even do the domain. I guess you could do it, but it takes a little bit of visualizing. So the center is at negative 1, 2, and 1, 2, 3. So there's the center, and it has a radius of 3. Well, if it has a radius of 3, it's going to go 3 in all directions. So it's going to go 1, 2, 3. That's the far right boundary. And then 1, 2, 3. That's the far left boundary. 1, 2, 3, 1, 2, 3, and there's your circle. Oh, not bad. Okay, there's my circle. Now, what is my left boundary? The left boundary is negative 2, negative 3, negative 4, negative 5, and the right boundary is at positive 1. So the domain in this case would be x is greater than negative 5, greater or equal to, let me fix that a little bit. Let me rewrite it. So negative 5, x is greater than negative 5, but less than or equal to positive 1. All right, now let's look at the domain. Oh, excuse me, the range. So the range goes from 0 all the way to, if that's 3, 4, 5, 6. Okay, I guess I could have just added the radius to both of the, added and subtracted the radius to both of these values to get it, but it's a nice way of doing it visually. Okay. Okay, example number 4. Now we have to come up with our own graphs. And here's our condition. So draw a graph of a relation which has a domain that with an x is all reals and a range of y is less than 2. So let me first find where y equals 2. Well, y equals 2 over here. So that's going to be my boundary, or at least one of my boundaries. Let me just do let me go back up a little bit here. There we go. Oops. So that's my boundary right there. So I'm going to put a dotted line. And because y is less than 2, I know that this upper half here, or upper portion, is is not going to be, that's not going to be where the graph is. Okay. The other important point here is that I'm only allowed to have one x-intercept. Okay, so I can do something like that where where I have two x-intercepts. Okay, so what I'm going to do here, and again, you can get pretty creative here. So I'm thinking something along the lines of, well, first of all, it has to go through 2. So let me go through 2 over here, and then I'm going to go down forever this way. Okay, that'll satisfy x is less than 2. But now what I'm going to do is I might do something like this, where I keep going horizontally this way, but never actually drop below the x-axis. So that'll only give me one x-intercept. Okay, two x-intercepts, well, that's that one there. And then this one, explain why it is not possible to draw a graph which has a domain all real numbers, but no x-intercepts? Well, if you have no x-intercepts, and I have to be below 2, and I have to keep going forever, well, eventually, I need to cross the x-axis to go down below here. I need to cross the x-axis. So if I'm going to include this and these conditions, they basically contradict each other. You can go down forever and not cross the x-axis. Okay, I'm going to let you do example number 5 at home. I think this is very similar to the problems we've been doing last class. However, when you do get to question C here, make sure that your domain, again, this is a little different now because this is a real life example. Instead of x, we're going to have the number of people, and it should be between 100 and 500. And the cost, again, this is now your y value, your cost should be between 2,500 and 10,500. Okay, so go ahead and go through this example and make sure that you're able to get these values for your domain and range. Okay, thanks for watching, and see you next time.